Diving too deep for coins, all of your street light eyes wide on my plastic toys. Then when the cops closed the fair, I cut my long baby hair and stole me a dog-eared map. Called for you everywhere. Have I found you? Flightless bird, jealous. Then lost you. Where again now? Now I'm a fat house in the cat, testing my soul out of watching boys and bands go through the white grass. Is it on magazine? All of those fish and boys all have to go down. But the cries mountain stream. And I found you. Let's
Hello everyone, can you hear me, guys?
Yes, 老师。
Okay, so let's.
老师。
Okay, 你好. Okay, let's start our class today. From last week, we started to learn what is a definite integral. So first, we will review the expression of the definite integral, that is a b fx dx. And here we call a is the lower limit and b is the upper limit. And here fx is the integrand with the variable x here. So this is the definite integral. And then we have learned the geometric meaning of the definite integral. If x is larger than 0, that means the area of the region, right? So that is the geometric meaning for the definite integral, and we can calculate the definite integral without formulas. From the geometric meaning, sometimes we can calculate directly, right? And I have gave you some examples last week. And if fx is smaller than 0, for example, maybe sometimes the graph of the function f of x that lies below x-axis, right? So the definite integral, the value of the definite integral, that is the negative update constant of the area. So here that equals minus area here. And if that is above the x-axis, maybe we can call the area here that is A1, and here that is A2. So that means A2. And if function is graph sometimes below x-axis, and sometimes that is above x-axis here, like this. And for example, this part, the first part, this is A3. And this part, that is A4. And this is the graph of the function f of x. So here is A, B. Then from A to B, fx dx, that means A4 minus A3. A4 minus A3, right? Because this part, that means the opposite value of A, right? So this is the geometric meaning of the definite integral. So in the end, we talked about the definite integral, and we know actually the result of the definite integral, that is a constant here. So if you calculate the definite integral, you will get a value, you will get a constant at last, not a function plus c. So you have to know that. And then we have learned the properties of the definite integral. For example, we know that here we know that if the integral that are the summation of two functions here, fx plus gx, that means it equals from A to B fx dx, and then plus from A to B gx dx, right? And second, if the integral that is a constant k times f of x, so that equals, we can take the constant k outside the definite integral. So that equals k times from A to B fx dx, right? And then if we want to calculate the definite integral and the interval from A to B, that can be subdivided as from A to C and from C to B. Then the definite integral can be separated to two parts as well. So this is the third property of the definite integral here. And we have set two rules here. That is, I will write here, that is from A to B, fx dx, that equals minus from B to A, right? fx dx. If we exchange the lower limit and the upper limit, then you have to add the minus sign before the definite integral. And then if the lower limit and the upper limit, they have the same limit here. Here, that is from A to A. Here. And we say that equals 0. That equals 0. And here is the things we have learned last week. And then there are two more property here you have to know. The first, I will write here number 4. And number 4, that is if a function on the same interval, for example, from A to B, and the function f of x is always smaller than the function gx, then the definite integral from A to B fx dx, that is also smaller than from A to B gx dx. So here is the property number 4. And number 5, that is, if you want to calculate fx from A to B, fx dx, and that will be equal to, you can find a constant c that lies between A and B. And then from A to B, fx dx, that will be equal to f of c times the length of the interval, that is from B minus A here. So this is the property number 5. So here are 5 properties you have to know. And then here we will calculate a definite integral that is from minus pi to pi sine x dx. And now we didn't learn any formulas for definite integral, right? So here, the only way we can use that is the geometric meaning of the definite integral. So here, you will know that the graph of the function sine x, that is like this, and here is minus pi here, and here is pi. And we know the geometric meaning of this definite integral. That means the area of the shadow part, right? And you will find, for example, here the area that is A1, and here the area that is A2. From the graph, you can see that A1 equals to A2, right? And we will use the geometric meaning for calculating the definite integral here. That will be, here we use this equation, right? If we have lower part and upper part, so that means the positive part minus here lower part, right? So that will be A2 minus A1, right? And we know A1 equals to A2, so the result here, that is 0. And from this example, we can summarize 2 more properties for calculating definite integral here. So number 6, that is, if the function f of x, that is a continuous function on the interval from A to B, from minus A to A. So here I will use a symbol here, that is fx in C closed interval from A to B. Here, This symbol means on the closed interval from A to B, all the continuous functions. So here, that means f(x) is a continuous function in the closed interval from A to B. You should know that. And the interval here, that is a special interval. That is a symmetrical interval from -A to A here, from -A to A here. And then we will consider two kinds of functions. The first, that is, if f is an odd function. Anyone knows what is an odd function? Here, that means
Yeah,
f, no, okay, that means f of minus x equals to minus f of x here. For example, I will give you an example. For example, the function y equals to x, this function. And you will consider, maybe I will write f of x. That is more clear for you here. So here, for example, the function f of x equals to x here. And if you want to check this function is an odd function, you can substitute f of minus x here, minus x. And from the rule for this function, that means the value of the function equals to the variable here, right? So f of minus x, that equals minus x, right? And x here, that equals f of x. So that equals minus f of x. So from the beginning to the end, we know that the function f of x, that is an odd function. Can you understand here, guys? Any questions here? How to check?
Lasha, can you repeat again, please, this line?
Okay, I will give you another example here. For example, f of x, x power 3 here. Okay, if a function that is x power 3, then if you want to check if it is an odd function, you can substitute f of minus x, right? And if you substitute x minus x here, that equals to minus x power 3, right, guys? And here, minus x power 3, that equals to minus 1 power 3 times x power 3. And minus 1 power 3, that equals minus 1, right? So here, that equals minus x power 3 here. And minus x power 3, that equals minus f of x here. Because the function, don't forget that, the function that is fx equals x power 3. So here, x power 3 also equals f of x. So we can see at the beginning, that is f of minus x here. And at the end, that is minus f of x. So we know that f of x equals x power 3. That is an odd function. Can you understand more clearly here?
Yeah, Lasha.
Okay, so here, if you can check that f of x, that is an odd function, then we have a conclusion here that is, then from minus a to a, f of x dx, that equals 0 here. The value, the result of the definite integral always be 0. So here, actually here, we use this property. Sin x, the function sin x, that is an odd function. And the interval here, that is a symmetrical interval. So we know that equals 0 here. That equals 0 here. So if I want you to calculate, for example, from here, this function f of x equals x here. If we want to calculate from maybe minus 1 to 1 x dx, that will be 0. You can write 0 directly from this property. And the same from minus 1 to 1 x power 3 dx also equals to 0 here. As long as the interval that is symmetrical interval and the function is an odd function, then you can write 0 directly without calculating. Okay, this is the first part of the property number 6. And the second part, that is, f is an even function. F is an even function. Even function means f of minus x equals f of x. I will give you an example here. For example, if fx equals x power 2. So guys, you can check that f of minus x here, that will be minus x squared, right? And that is x squared. And x squared, that is f of x. So here we know that f of x here is an even function. So if f is an even function and the interval that is symmetrical, so we know the result here, number 2, then from minus a to a, f of x dx, that equals here 2 times from 0 to a. Here you will find that from 0 to a, that is half of the interval from minus a to a, right? So that equals 2 times from 0 to a, f of x dx here. F of x dx here, okay? So here we have learned 2 more properties here that use the property of the function. So here you should know the odd function and the even functions here, and you can use it. Here, the odd function we usually use, that is sin x, right? Fx. This is an odd function. And here, the even function we always use here, that is cosine x here, cosine x here. So if you see sine x, you should remember that is an odd function, and cosine x, that is an even function here. Then you can calculate directly from it. Okay, so here are 2 more properties for the definite integral. And then we will try to, here, we will try to calculate a definite integral, although we didn't know the formulas here. That is from a to b. The integral, that is x dx here. So here, guys, please think about it, how to calculate this kind of integral. And now we still use the geometric meaning of the definite integral to calculate it. So here, the first case that is the easiest one, that is A and B, they are larger than 0. So here you will see f of x integral here, that is fx equals x, right? So we know that is a line passes the original point, right? So here that is f of x equals x here. And then if A, of course, B that is larger than A, larger than 0 here, or equal to 0 here. So you will know it is A maybe, and it is B maybe. And the definite integral here, that means the area of the shadow region here, right? And we know how to calculate this shadow region from the formula, right? So that will be half times here. The length of this one, that is FA, right? Here we can substitute A into this function. So that is A, FA, that is A. And here, the length here, that is FB, right? So that is B. And we know that is A plus B times the height here, right? The height, that is the length of the interval. So that means B minus A here, right? B minus A here. So we know that equals half times B squared minus A squared. That equals B squared by 2 minus A squared by 2. So can you understand how I calculate this definite integral here? Guys?
No, Lordship.
No? Do you know how to calculate? I will draw again here. Trapezoidal region. Do you know how to calculate the area of this trapezoidal region? Do you know the formula? If the length here, that is maybe A1, here the length, that is A2, and the height here, that is A3. So the area of this trapezoidal region, that is half times
Length into height.
Yeah, A1 plus A2 times A3, right? Okay, so we use this formula. And in this region, okay, you can match one by one. Here, A1 here, that is this part, right? The length. And the length here, that is the value of A, right? Because this point, that is x equals A here. So FA, of course, equals A. So here A1, that is A. A1, that is A. And here A2, this part. A2 here, that is this length, right? And of course, we know that FB equals B because here Fx equals X, right? This is the function. So the length here, that is B. So we have A1 plus A2, that means A plus B here. And times the height here, A3. And the height, that is this part, right? This is the length. And the height, that is B minus A, right? Because it is B, and it is A, right? So of course the height that is B minus A here, A3 here. So we know that the area of this region that is half times A plus B times B minus A. And we make these two parts together. That is B squared minus A squared. I think you know that. And times half, 1/2. So that equals B squared minus by 2 minus A squared by 2. Here we have the result, this one. Okay, and I know most of you are not good at drawing the graph, right? So from today we will learn a method that will calculate the definite integral without drawing the graph. Of course, not every graph we can draw out, right? So here we will learn a way that can calculate most of the definite integral. So here we call it fundamental theorem, and we will separate to two parts. So this is the key topic of today, a fundamental theorem here. So we will learn part 1 first. And part 1 says, this graph again. A, B, y equals f of x. Okay, and so here we know that the area of this region, that is the definite integral here. And you will see if I pick a point between A and B, for example, here, I pick this point. Maybe this point, I call it x sub 1, okay? And I will get a new definite integral here. So I will write it again. That is from A to x1, f of x dx. And from A to x1, f of x dx, that means the area of here, this part, this blue part, right? This is the area. So this definite integral means maybe I can call it A1 here, the area of the part A1. And if I choose another point between A and B, maybe this point, and I will get a new definite integral again, that is from A to x2, fx dx. That equals, maybe I can call it A2 here. So you will find that A2, that is the region between the x-axis and the function f of x, and the line x equals a, and the line x equals x sub 2. So this part, this is the area. So you will find every time I pick a point between A and B, you will get a new area, right? So it is a function. It makes a function with respect to x here, variable x here. And the result, that means the area of this region. So here we will get a new function. And that function, sometimes we use this symbol. Or I write an easier one here, capital F, okay, capital F here. That equals from A to X. f of x dx. And here, x, that is from a to b here. Here it is a new function. And this function, it has a special, here, if I want to make it clear here, I can change the letter here. Because you know that the definite integral here means the area. So no matter which letter I choose here, it always means the area here. So here, I can change the letter to t, dt. Or if you want to use the letter u, v, any letter is okay here because it has the same value. So here, if I want to make it clear, I can write the function as from a to x, f of t dt here. So I got a new function, capital F of x, that equals from a to x, f of t dt here. And if we use the definition of derivative, you can check that capital F, this is a key point here, capital F of x, that is an antiderivative of the function f of x here. So this is the key point. Capital F is an antiderivative of the function f of x. And that means capital F prime equals f of x. And that means if I substitute the expression here, that means d by dx, here that is from a to x, f of t dt, that equals f of x. So here, if I want you to calculate the derivative of this definite integral here, you can just first step find the integrand and then change the letter t to x. For example, here. This is a very, very important property for this function, and you will use later. Here, for example, if I want to calculate, maybe here that is d from a to x cosine t dt, that equals what? So here you don't have to know how to calculate this definite integral because you cannot here, right? So here, from this property, you should know that equals to f of x. So follow my step here. Follow my step. The first step, find the integrand. Integrand, sorry. A spelling mistake here. Integrand. And then the second step, change all the letter t to x. That is the result I want here. So guys, first find the integrand. So from this example, we know the integrand here, that is cosine t, right? Cosine t. So you have find integrand, that is cosine t. And then the second step, change t to x. So cosine x. And we know that the result here, that is cosine x. So guys, can you follow my step?
Yes, Laoshi.
Okay, so remember to find the integral, that is very important. So I will give you another example. Second one, here. Can you fill in the blank? What is the result of this example here? Give you 1 minute. So anyone got the result?
1 by 1 plus x squared.
Yeah, 1 by 1 plus x squared, right? Good. So here, follow the steps here. First, find the integral. So in this question, the integral that is 1 by 1 plus t squared, right? And the second step, change t to x. So we can write the result directly. That is 1 by 1 plus x squared. So although the expression here, that is a little bit complicated, right? But the result, that is easy. You just first find the integral and then change t to x, and that is correct. So here, I will give you a third example here. So please calculate and paste your answer in the WeChat group. Let me see it. The lower limit is x. The upper limit, that is 5. And here, 3t sine t dt equals to what? If you have finished, you can send your answer in the WeChat group. And let me check. Want to complete this question correctly, so please be careful to compare the formula in the blue rectangle and the question. compare these two parts and check again. Yeah.
Is correct also?
Yeah, yes, correct.
Okay, got it.
Yes, if you check again, you will get the correct answer, because here, first, guys, you should compare. Here, the definite integral here in the question, that is from x to 5, right? And in the formula, that is from a to x, right? And a can be any constant. A can be any constant. But x is the variable, right? X is the variable. So here, if we compare it, you will find the lower limit should be a constant and the upper limit should be x. Then we can use the formula directly. So the first step, you should know that, I will write here, the first step, we should exchange the lower limit and upper limit of this definite integral to match the formula here, right? So the first, if I want to exchange the lower limit and upper limit, I have to add the minus sign here, right? So that equals from 5 to x, 3t sine t dt, right? And then we can calculate. So d from x to 5, 3t sine t dt, that equals here minus d by dx from 5 to x, 3t sine t dt here. Then we can follow the steps. First, find the integrand here, and the integrand here, that is 3t sine t here, right? And change all the letter t to x. So the result here, that is minus, don't forget the minus sign here, minus 3x sine x here. Can you understand, guys?
Yes, also.
Yeah, so don't forget the sign minus here.
Roshi, can you repeat again?
Okay. First, the formula here. Okay, I will write it again beside it. That is d from a to x, ft dt equals f of x here. And here, a can be any constant here. So a stands for a constant. And in our question here, a stands for 5 here, right? So it doesn't matter. No matter which constant it is, it will not affect the result of this question. So here, if I want to use this formula here, you should pay attention to the lower limit and upper limit here. The lower limit is a constant and upper limit, that is a variable x, right? So here, in the question, the lower limit, that is x, and the upper limit, it is a constant. So the first step, we should exchange so the first step, that is here, we exchange the lower limit and the upper limit. Here you will find that match the function, the formula here. So if we exchange these two limits, don't forget to put minus sign here. We have reviewed this part, right? We have reviewed A to B, from A to B, that equals minus from B to A, right? So here we have a minus sign before the definite integral here. And then we can use this formula. That is, first we change it to from 5 to x. And then we found the integrand here, that is 3t sine t. And then we change all the letter t here, all the letter t to x. So you will find that is minus 3x sine x. Okay, guys? And we will have a question number 4. And that is to calculate dy by dx. And here, y, that is from 1 to x squared cosine t dt. So for this question, you will find that things are more complicated because the upper limit here, that is not x. It is a function x squared, right? It is x squared. So we cannot use the formula directly, but we can do something to change this definite integral to match the formula. So the first step here, we use the substitution rule here. So first, you can let u be x squared here, right? And then y equals from 1 to u cosine t dt. And you will find this here, the function here, that match the formula, right? So dy by dx, that equals dy here, dy by what? Here, the variable that is u. So dy by du times du by dx, right? So it's sometimes like the chain rule, right? Like the chain rule. So here from by dy by du times du by dx. So you will see dy by du, dy by du here. That equals, we can substitute y here, from 1 to u cosine t dt, right? And that equals, first we find all the find the integrand, and then change t to the variable here, that is u, right? So that is cosine u here. So the first part, that equals cosine u, and then times du by dx, and u equals x squared, right? So du by dx, that means 2x. That means x squared prime, right? So 2x here. So we times 2x. And then the last step, we substitute u back here. So that equals 2x times cosine x squared. So the result here, dy by dx, should be 2x times cosine x squared. So you should know that if the upper limit, that is a function of x, right? It is a function of x. So you should first step find the integral and then substitute it to t, and then don't forget to time the derivative of this function. So that is 2x times cosine x squared. So here I will give you another formula and I will write it here. Below. The formula number 2. That is d by dx from a to phi x. Here phi x means a function of x, or you can use other symbol. So here, maybe you can write gx here, ux here, and one is okay. So here that is ft dt, and that equals, first we change t to phi x. So here the first, that is f of phi x, and then times phi x prime. So this is the second formula for this special function. So here I will give you another example. So here, example that is calculate the from 1 to sine x 3t squared dt. So first, you should think about which formula to choose, number 1 or number 2. So here I will give it a number. This is number 1 and this is number 2. So first, you should make a choice which formula you want to use, number 1 or number 2. As long as you see here, that is a function. For example, here, sine x, not x itself, then you should choose the second formula here. That means it is a composite function. So here you should know the first step, that equals, you also find the integral here, 3t squared. Then you put this function to t, so that equals 3 times sine x squared, outside squared, and then times the derivative of this function, sine x prime. So that equals 3 sine x squared. You should write square here, not after x, okay? And then times cosine x. So this is the result of this question. Can you understand how I used the formula number 2 to solve this question? Any questions here?
Oh, sure.
Yes.
So we simply using this formula, the number 2, just in case G is this upper thing, and how we get this one, cos 6.
Okay, so
Where?
here, okay, how to choose formula number 1 and number 2? You just check the upper limit here. Okay, I will write here. Check the upper limit. The lower limit should be a constant. They are the same, right? And the upper limit, you should check If the upper limit, that is x itself, only x here, then you choose number 1. If here it's a function of x, I write phi x here, or you can write gx here, then we choose number 2. Can you understand? Of course, sine x here means a function of x, so we choose number 2. And at the examples here, from 1 to 3 here, you will find x itself here, only x here. So we choose formula number 1. Can you understand now how to check which formula to use?
Yes, Lasha.
Okay. Any other questions? Anyone has other questions? No? Okay, so I will give you more exercise here. You should know how to choose the formula to get the result. The first, so try to solve these 4 questions. And if you have finished, you can send your procedure in the WeChat group.
Lasha, can you please show the first formula just for a second?
Okay. The first, that is above. Okay, I will write beside the 2 formulas here. That is and the second okay, these 2 formulas.
Yes, Lasha.
Okay, welcome.
Lasha, I have a question.
Yes.
It's about the second formula. So why we are having this one? Because of the dt? The
No, here. You can see as this example here, number 4.
Yeah,
If the upper limit that is a function of x, then we cannot use formula number 1 directly because number 1 that is the x itself, right? So here I use the substitution rule here to let x squared be u, right? So I change the variable here to u, So you get dy by du from the first formula directly, cosine u. But I want you to calculate dy by dx, right? Not dy by du. So if I want to calculate dy by dx, that should be dy by du times du by dx. And here du can be removed. So that is dy by dx. Okay, so the first part means dy by du, and the second part, as you are asking, that should be dx by du by dx. You cannot miss this part, du by dx here. So that is phi x prime part. That is why we should use this part from the chain rule here. Can you understand?
yeah, yes, Lasha.
Okay.
Thank you.
Here, Roy, since you are late, we are now learning these two formulas. So you can first write down these four exercises, and then I will explain how to use these two formulas, okay? Okay, let's solve these four questions together. And for number 2. Number 2. So here you will find that the upper limit is square root of x, right? So obviously we'll choose formula number 2 here. So we follow this formula. First step, you should treat this function upper limit as a whole and substitute it into this function f in place of t, right? So first, I will mark here. This is upper limit, and here is t, right? So replace t here, first step. So the first part should be cosine square root of x, right? And then times phi x prime. That means square root of x prime. And that equals cosine square root of x times here. Square root of x means x power 1 by 2. So we use the formula that equals 1 by 2 times x power 1 by 2 minus 1, right? So that equals x power minus 1 by 2. So that should be 1 by square root of x. So that is 1 by 2 times square root of x times cosine square root of x. These two square root of x cannot be cancelled because this part that is inside the function cosine. So they cannot be cancelled. This is the result for question number 2. Can you understand or any questions here for number 2? Okay, no questions. And number 3. Number 3, same way, the first. Here, the upper limit, that is x power 4, right? So treat it as a whole and replace t here. So the first part should be square root of x power 4, and then times x power 4 prime. So that equals first part, that is x squared, and second part, that is 4 times x power 4 minus 1, right? So that equals 4 x power 2, x power 3, so means x power 5 here. So this is the solution for number 3. Any questions here?
No, Lashe.
Okay, good. And number 4 here. This is a question. I want you to be confused, but I'm really happy that most of you figure it out. Here, the upper limit, that is x itself here, right? So we can use the first formula directly. So we just first step, find the integrand, then change all the t to x. So that equals square root of 1 plus x squared. And here, actually, you can only remember the formula number 2, because if I use number 2 to solve this question, it also works because here you can treat x as phi x, right? So you can replace t to x. So that also equals square root of 1 plus x squared and times x prime, right? Upper limit prime. And x prime equals 1. So that equals square root of 1 plus x squared here. So it has the same result. So you can use number 2. You can remember number 2. That is enough for these kind of questions. So the last one, number 5. Number 5. So first, you know, we have to exchange the lower limit and upper limit. So that is really good. So first, we change the lower and upper limits. We add the minus sign here, so that equals d by dx from 0 to x power 3, and then sine t squared dt. So this step, we just exchange the two limits and add the minus sign here. And then we know we should use number 2 formula. So here you will find the upper limit, that is x power 3, right? So the first, you should replace t by x power 3. So that is sine here, x power 3 power 2 here, right? And then times x power 3 prime, right? So we will simplify it to equals sine x power 6 here, right? And times 3x power x squared. So we know that equals 3x squared sine inside function x power 6. So here are the solutions for these 4 questions. So do you have any questions? Do you have any doubt about it? No questions?
No, Lashe.
Okay, good. So here I will give you the last exercise here. So please fill in the blank for the following 3 questions. First, second, third, please fill in the blanks. Okay, let's solve it together. For the first one. Okay, for the first one. So you will find this part. It is a definite integral, right? Although we cannot calculate the value, the result of this definite integral, but you should remember the result of this definite integral that is a constant, right? So this part you should remember it means a constant. And then the derivative of a constant should be 0, always be 0, right? So the result for the first one should be 0. Can you understand, guys?
Yeah, Loshi.
Okay. And number 2, second. Second here, I write x here to make you confused. But as we have talked about, here you can use any letter to replace x here. So I write x, you can write t, right? So here you should know that we can use the first formula. We just find the integrand first and then replace t by x. So the integrand here, that is sine inside function t squared. So we replace t to x, that is sine x squared, right? So this is the result of the second one. And the last one. The last one, you should know what indefinite integral means. We have talked about indefinite integral means find one antiderivative and then plus c, right? So you should remember that sine x squared dx, that means if you can find one antiderivative here. Antiderivative means its prime equals sine x squared, right? This is antiderivative. So if we can find one antiderivative, I will write capital F here. So this indefinite integral means capital F of x plus c, right, guys? So here, this symbol means we want to calculate the derivative. So here, it equals d capital F of x plus c by dx, right? And here, that also means capital F of x plus c prime, right? It has the same meaning. And then we use the sum rule, and that equals capital F of x prime plus c prime, right? And capital F of x, remember that it is one of the antiderivatives of this function. So capital F of x prime equals this function sine inside x squared. And then plus c prime. C is a constant, right? So c prime equals 0. So we have the result of the third question here. That is sine inside function x squared here. So it is the result for the third one. Can you understand, guys?
Loshi, can you repeat again, please, the last one?
Okay, the last one. Okay. So here, you should understand this question number 3 part by part. So first, we should make it clear what this part means, this part here. And it is an indefinite integral, right? And we have learned about that indefinite integral. That means all the antiderivatives of the function f of x. So of course, you can choose one antiderivative. And antiderivative means S prime equals f of x. So that equals capital F of x plus c, right? This is the definition of indefinite integral here. So here, you can suppose that capital F of x, that is an antiderivative of this function, because here we can see the integrand that is this function, right? So if I suppose capital F of x, that is an antiderivative of this function sine x squared, then this indefinite integral should be capital F plus c, right from the definition here. And we have known what it is. And then the second step, we calculate d by dx. And d by dx, we know that means to calculate the derivative here, right? And we can use the sum rule to calculate part by part. So that equals first capital F prime plus c prime. And capital F prime, as we have supposed, that is the function itself, right? So that is sine x squared. And then c prime means 0. So we have the result, that is the first part, sine x squared, this function. Can you understand?
Yeah, Laoshi.
So here we should know first the definition of indefinite integral, and then we should know how to calculate the derivative. So here, don't forget what we have learned before. And the last question, we will solve it after the break. But now I will show. The question first. That is to calculate limit as x approaches 0, 1 by x power 3 from 0 to x sine t by t minus 1 dt. And you have a long time, maybe 15 minutes to think about it and try to solve it, okay? So now we will have a 15 minutes break from now. Okay, guys? Go
Okay,
and
Laoshi.
do that first, okay? See you then. Guys, let's back to class.
Yeah, she will come back.
Okay. So please think about the last question, number 7. Anyone has any idea about how to solve this question? Yeah, of course. This question, we should calculate the limit. But we will think about which way we should use to calculate this limit. Anyone has any idea? Okay, so here, yeah. So here, please think about it. As x approaches 0 here, 1 by x power 3 times this part, right? And we can treat it as, I can write it as this form. Right? They are the same, right? Here, I have put this part together up. And then as x approaches 0, we know x power 3 approaches 0, right? So here approaches 0. And here, if x approaches 0, you will find the lower limit and upper limit are both 0, right? So that is also 0. So here, remember that if we meet the condition 0 by 0, what should we do to calculate the limit? We have learned a rule here. If you see 0 by 0, can somebody remember that? 0 by 0 type.
Yes, Lucy, hospital rule.
Yeah, good. That is L'Hopital's rule, right? So here, we will use L'Hopital's rule to calculate this limit. So that equals here, as x approaches 0, we calculate the derivative up and down both, right? So here, down, that is easy, 3x power 2, right? X power 3 prime means 3x power 2. And here, from 0 to x, sine t by t minus 1 dt. If we want to calculate the prime, that means this type, right? And we have learned it just now. That equals here, the upper limit, that is x itself. So we can find the integrand first, and then change t to x, right? So that equals sine x by x minus 1 here. So about this step, anyone has any questions? Can you understand? We use L'Hopital's rule here. And then next step, we have to simplify the function here. So that is as x approaches 0, we simplify it. So we know that sine x by x minus 1 equals sine x minus x, right? And we can put this x down here. So that equals sine x minus x, 3x power 3, right? Okay, and then that equals, here you will check again. If x approaches 0, 3x power 3 approaches 0, right? And approaches 0. And here, sine 0 means 0, minus 0, so also approaches 0. So it is still a 0 by 0 type. So we can use L'Hopital's rule again here. So that equals, as x approaches 0, first, sine x minus x prime means cosine x minus 1, right? And then 3x power 3 prime means 9x power 2, right? And then we can check again. As x approaches 0, it approaches 0, right? And here, as x approaches 0, cosine 0 means 1, and 1 minus 1 also 0. So it is again 0 by 0 type. So you can use L'Hopital's rule again here. So that equals x approaches 0 here. Cosine x minus 1 prime means minus sine x, right? And then by 18x. And now we can get the result. Here, we can take the minus sign out, and then we take the constant 1 by 18 out. And then we will find that is as x approaches 0, sine x by x. Can you remember? This is an important limit we have learned. And the result of this limit, that is 1, right? So the result, that is minus 1 by 18. Okay, here are the solution for this question. And as you can see here, we use L'Hopital's rule. We use how to calculate the derivative of this kind of definite integral. And we use the important limit, the result of the important limit. So in this question, it is a very flexible question. So when we meet some questions that is a little bit complicated, please think more about it, what we have learned. So about this question, do you have any doubt to ask here? No questions? No questions here? Okay. So we have learned before the break the first part of the fundamental theorem. That is how to calculate this kind of definite integral. And from this definite integral, actually we have the second part of the fundamental theorem. And this part, we use it to calculate the definite integral without drawing the graph. So here, the theorem that says if the function f, that is a continuous function in the closed interval AB, and you can find one antiderivative of this function f. So here I will write, you can find one antiderivative of the function f of x. Then, if we want to calculate the definite integral from a to b, f of x dx, that equals capital F of b minus capital F of a. So this is a very triple star important formula to calculate the definite integral. And it is more useful than drawing the graph. For example, at the beginning of the class, remember that I want you guys to calculate from a to b, x dx at the beginning. X dx, right? And we use the formula to calculate the area. And then we got the result that is b squared by 2 minus a squared by 2 here. Right? And now let's check. If we don't know how to draw the graph and we don't know the formula either, then how to calculate this definite integral using this formula. So here, follow the theorem. First step, we should find an antiderivative here. So how to find the antiderivative? That is indefinite integral thing, right? We have recite many formulas. So here, the function that is x, So which function's prime equals x? Just find one. I think you guys can find it. That is x squared by 2, right? You can use the formula we have learned, that is x power n dx equals 1 by n plus 1, x power n plus 1 plus c here, right? And here n shouldn't be minus 1 here, okay? So you will find the first part of the formula, that is one of the antiderivatives. And that is what we want for Captain F. So here, the power here, that is 1, right? So we can use it, that is 1 by 2 times x 1 plus 1. So that is x squared by 2. So you have find one antiderivative for it. So from the formula, that should be capital F here, that is x squared by 2 here. So from the formula, first, we substitute the upper limit into this function. So that is b squared by 2. And then minus the lower limit you substitute into this function, that is a squared by 2. So as you can see here, we can also get the result from this formula without drawing the graph here. So can you understand how I use this formula to calculate this definite integral? Can you understand, guys?
Yes, lesson.
Yes.
No, can you repeat again, please, this?
Okay. I will give you another example here. Maybe we can calculate here. And number 2 here. Please calculate from 0 to 2 x squared dx. So guys, first, I will show you the formula here. From the formula, first find one antiderivative. How to find one antiderivative? We can use the basic formulas we have recited before, right? The first part, this part, without plus c, that is one of the antiderivatives, right? So here, x power 2, x power 2, you can find one antiderivative that should be 1 minus here n equals 2, right? So 2 plus 1 and times x power 2 plus 1. So that is 1 by 3 x power 3, right? And you can check capital F prime equals 1 by 3 x power 3 prime equals 1 by 3 times 3 x power, that is x power here, right? So it is one of the antiderivative we want as capital F here. And then from the formula, that equals, as long as you have figured out which one is antiderivative function, then you first substitute upper limit into this function. Here, the upper limit, that is 2, right? So you first substitute 2 into this function, that is capital F of 2. Then minus the lower limit here, that is capital F of 0 here. And then we can calculate. First, we substitute 2 into this function. That means 1 by 3 times x power 3, right? So 2 power 3. And minus 1 by 3, 0 power 3. So this part, that is 0. And that equals 1 by 3 times 8. So equals 8 by 3. Equals 8 by 3. Can you understand, guys?
Yes, Lashes.
Other students, do you have any questions? Any questions here? No? Okay. Okay, I will give you another simple example. So please try to solve it by yourself. First two questions are really simple. Number 3 here. From -2 to 0, 2x plus 5 dx. And number 4 here, that is from -3 to 4, 5 minus x by 2 dx. So try to first calculate these two definite integral by the formula above. I will make it smaller to let you see the formula here. Okay, this part is the formula. I will circle it by red pen here. This is the formula. Okay, so try to calculate number 3 and number 4, these two questions. Try to calculate by yourself, guys. Because these questions are the basic ones, we can use the formula we have remembered before directly. And then we can solve some complicated ones. So this is the first step, the basic level for calculating definite integral here. Okay, let's solve it together. For the first one, number 3, if we want to calculate this definite integral, so first you should find one of the antiderivatives, right? So how to find antiderivatives here? You can use the formulas for indefinite integral. That means you can first calculate indefinite integral. And if we calculate this indefinite integral, we know here that should be 2 times. Here x means x power 1. So that is 1 by 2 x power 2, right? And then don't forget to plus this part, not 0. When we calculate the derivative of a constant, that is 0. But now we are calculating integrals, right? So here you should know that means 5 is a constant times 1. 1 means x power 0, right? So here we plus 5x here and then plus c. So that means x squared plus 5x plus c. And x squared plus 5x, that is the antiderivative we want. So for number 3, we know the definite integral should be, you have first found one antiderivative here, x squared plus 5x here, right? And then we should substitute lower limit and upper limit, right? So here, you can use a symbol here, and we write -2 lower and 0 upper. Means you have found antiderivatives here, and the lower limit, that is -2, the upper limit, that is 0 here. And then from the formula, you first substitute the upper limit inside this function. Obvious, that is 0, right? And then minus, you substitute -2 into this function. So that means -2 squared plus 5 times -2, right? So we know that should be minus outside. Here, that is 4. And here, -10. No, means 6 at last. So the solution for number 3 should be 6. The result should be 6. Any questions here? Guys, do you have any questions? No? No questions, right?
No loss.
Okay, so we will solve number 4 here. Number 4, and this is number 3. And number 4, I will change the color here. Number 4, okay. So you are still focused on calculating, right? So here, number 4. Number 4, you also first find the antiderivative for this function. So you can first calculate 5 minus x by 2 dx, and we still use the power formula, right? So for the first part, we know that is 5x, and then minus the second part, that is 1 by 2, times 1 by 2 x power 2. So that should be, or plus c, so that should be 5x minus 1 by 4 x power 2 plus c here. So this function is the antiderivative we want. So the definite integral should be 5x minus 1 by 4 x squared from -3 to 4. So we first substitute 4 into this function, right? We should substitute 4 first. So that is 20 minus here, that is 1/4 times 16, so means 4, right? And then minus here, we substitute -3 into this function. So that means -15 first, and then minus 1/3 times 9 here. So here means 3/2, right? So that is 16 plus 15, and then plus 3/2. So that means 31 plus 3/2. So in total, that is 65/2, right? Do you get the same answer here? No? Did I make a mistake here? Or you guys make a mistake here? So first, we have found the same antiderivative, right? They are 5x minus x/2, right? That is here, let me check. 5x minus x²/4. Okay, that is the same. And then you should know, yeah, here, that is 3/2. What is the question? Did I make a mistake? Here 16 plus 15, and then minus here, minus means plus.
Lucy,
Uh-huh.
Lucy,
Uh-huh.
is it not 20 minus 15 instead of 20 minus 4 that you wrote?
Here that is 1/2, and x means 1/2 x². So x²/4, it is correct.
Lucy, 9/4, and how it comes to 3/2?
-3. Here, 9/4. Oh, okay.
Divided by 2.
Yeah. Okay. I think that is 6/4. Okay.
Yeah.
Yeah. So that is 9/4. Okay. 9/4. So here plus 9/4. Okay, 9/4. Okay, so that means 124 plus 9, so means 133/4, right? Okay. Okay, so we have the same answer. So as you know, everyone make mistakes, right? So that is okay, we can check together. So it is the basic questions for how we can use the basic formulas to calculate this kind of definite integral. And then I will give 2 more questions here. So the third one, that is, okay, number 5. Number 5, that is to calculate from 0 to 1, x squared plus square root of x dx. And number 6 here, that is from -1, from 1 here, from 1 to -1, x plus 1 outside square dx. Okay, so please calculate these two definite integrals. Guys, pay attention to this step here. this step. When you calculate indefinite integral, you cannot write equal sign here. That means this definite integral equals this indefinite integral. That is not correct. You can calculate this indefinite integral separately, or you can use the formula directly as this part. But you can make this step equals this step. It is not correct. They don't have the same meaning, okay? Although they have the integral sign, but actually, indeed, they are not the same thing. So here, you can calculate 8 on the right part separately, and then write at this one. Okay, let's solve the questions together. The result for number 1, for me, that is 1. And number 2, that is minus 8/3. And I have double checked this time. So did you get the same answer here? From the WeChat group, most of you can get the first one, right? Okay, so here, let's solve number 5 first. Okay, number 5, when you calculate more, you can write it directly. So first, we can find the antiderivative here. So that is 1 by 3 x power 3, right? And then plus here, for this part, that is x power 1 by 2, right? So that is 1 by 2 plus 1 means 3 by 2. So here we plus 2 by 3 times x power 3 by 2. And then from 0 to 1. And then that equals, we can first substitute 1 into this function. So that is 1 by 3 plus 2 by 3. And then minus, we substitute 0 into this function, so means 0 plus 0, right? So that equals 1 here for the first question. Okay, and that let's solve number 6 here. Number 6. Few of you send the result of number 6 into the WeChat group. So first, if you want to calculate this definite integral, we should know x plus 1 squared means what? So we know that means from 1 to minus 1 here, right? And then here is x power 2 plus 2x plus 1 dx, right? So that equals, we can first find the antiderivatives here for these 3 parts. So that should be 1 by 3 x power 3, and then plus 2 times 1 by 2 x power 2, and then plus x here from 1 to minus 1 here. So 2 can be cancelled here. Don't forget the upper limit is minus 1 and the lower limit is 1. So we first substitute minus 1 into this function. That means minus 1 by 3 plus 1 minus 1, right? And then minus, we substitute 1 into this function, means 1 by 3 plus 1 here, right? So plus 1 minus 1 can be cancelled. So that should be minus 1 by 3 minus 1 by 3 minus 2. So that means minus 8 by 3 here. So here is the solution for the second one. Do you have any questions here? Can you understand, guys?
Yeah, Lashe.
Okay.
Yes, Lashe.
Okay, and now I will teach you another way to solve question number 6. Here, this one. Okay, for this kind of question, there is another way we can solve it by use substitution. And as we have learned when calculating indefinite integral. So here, we will learn a rule for calculate this indefinite integral. So that is substitution rule. So what means substitution rule here? We use this exercise as an example to show what it means. From 1 to minus 1, x plus 1 squared dx. Remember when we learned substitution rule in calculating indefinite integral, then we should first let a part be u. Then we can use the formula directly. Remember that? So from this one, we think we want to use this formula directly. We want to use it directly. So this part and this part, they should be the same. Then we can use this formula directly. So here, you know, we can first let u be x plus 1. And then, guys, you will find du equals dx plus 1 means dx, right? So du equals dx. And there is a third step here because the difference, the biggest difference between definite integral and indefinite integral, that is, definite integral, we have the lower limit and upper limit, right? So here, if you have changed this value to u, then you should find the limit for u. So here you have to change the limit for the new definite integral. So if x is from, here x is from 1 to -1. So here 1 means lower limit, right? And -1 means upper limit. So the range of x, that is from 1 to -1, and u equals x plus 1. So that means the lower limit of u is, we substitute 1 here. So the lower limit for u, that is 2. And the upper limit for u, we substitute -1 here. So that is 0. So we can find the range, the limit for u, that is from 2 to 0. So here, the original integral can be changed to from 2 to 0. U squared dx equals du, so du here. And then that equals, we can use this formula directly, that is 1/3 u power 3, and then from 2 to 0, right? And that equals, we first substitute 0 into this function, so that is 0. And then we substitute 2 into this function, that is 1/3 times 2 power 3, so means 8. So we can get -8/3 easily, right? We can compare these two ways here, these two ways to solve the same question, number 6. Obviously, this one, we use substitution rule to solve it, is more easier, right? We can get the same result. Here, you will definitely get the same result because that is the area of the shadow region, right? So it is only one result here. That is -8/3 here. So anyone have any questions about how I use substitution rule here? Any questions? No?
No, Ash.
Okay, so there is a common mistake here. That is, if you want to change the variable to u, then you have to remember to change the limit for you. This is the part, key part. Many students skipped this part, this step, and obviously he cannot get the final correct answer. So you have to change the limit from 2 to 0. Okay, so this is the way to use substitution rule for calculating definite integral. Okay, so I will show you another example here. And number 2. Number 2, please calculate from -1 to 1. 3x power x power 2 square root of x power 3 plus 1 dx here. So first, please try to calculate by yourself, and then we will solve it together. Try to use the substitution rule here. I will show you here. This question is similar to example 1. Okay, let's solve it together. And so first, okay, so first we can let u be x power 3 plus 1, right? And this is the first step. And then we will find du equals dx power 3 plus 1, and that equals x power 3 plus 1 prime dx, right? So that equals 3x power 2 dx here. So guys, you will find 3x power 2 dx makes du here. So the last step, you have to find the limit of the integration of u. So from the original limit, x takes from -1 to 1, right? So we know that u takes from, we first substitute -1 into this function because u equals x power 3 plus 1, right? So we first means -1 power 3 plus 1. So that is -1 plus 1 means 0 here. And 2, 1, we substitute 1 into this function. So that means 1 3 plus 1. So that means 1 plus 1 means 2 here. So we know that the limit of the integration for u should be from 0 to 2 here. So we know the original definite integral can be changed to from 0 to 2, and then should be here square root of u, right? And then 3x squared dx means du. So we have changed the original integral to a simple expression, right? So here we can get the answer directly. That is u power 1/2 means u power 3/2 times 2/3. And then from 0 to 2. So that equals, we substitute 2 into this function. So 2/3, 2 power 3/2, minus 0 here, right? And for this part, some students make mistakes here because this part means 2 power 3/2 means 2 power 3 and then 1/2, right? So that means 8 square root of 8. That equals 2 times square root of 2. So we can get the final result, that is 4/3 times square root of 2. And this is the result for this question. Any questions here? Any questions here for this question? We use substitution rule here. Few of you did correct. So, any doubt here for this substitution rule? So don't forget to change the limit here. Wow, you are so silent today. What happened? So any questions? No questions, right?
No,
Okay.
Laush.
Okay. Since all of you don't have questions, so I will give you a harder one. No question, right here, okay? Question number 3 here. Question number 3, from 0 to pi/2. cosine x power 5 times sine x dx. Sine x dx. So trying to calculate this definite integral. Calculating definite integral is, of course, on the final paper. So you have to know how to calculate it. Okay, guys? And next week, we will learn the last part of this chapter. And that is also the last part of this semester. So next week, we will learn something new. And the week after next week, we will have a total review. So next week, I will send the total review paper in the WeChat group. You have to download it and try to finish it. Then on the last week when we have class, you will know which one you did correct and which one you did not. We don't have time on the last class to give you time to okay. So next week we will learn something new, and the week after next week we will have a total review, and the third week we will have a final test, final exam. So I think you guys should know you have to review now from now on, or I can send the final review paper in the WeChat this week. So you can review as early as possible. Okay, guys?
Yes, Raushi.
Okay.
Maybe after class today.
Wow.
Yes,
Finally,
anything as soon as possible, Laushi.
finally you can talk. Okay. So in the last week when we have class, I will tell you how to finish the test paper. And the final paper, that is very similar to the test paper, but different questions. So you have to complete the test paper well and make clear every question. Then you can finish the final paper very quickly. Okay, guys? So for the last question, first you should know how to use substitution rule here. So you should know you have to let u be which function here. So try to finish it first. Question number 3. Maybe now talking about the exam is the only way to wake you up, right?
Raushi, math is so hard.
Really? So, So there is only one way to pass the final exam. That is to complete the test paper well. You have to complete it one by one question by one question by yourself, and make it clear, or most of them clear. So I think you will pass the final exam, although that is not easy.
Like she said, it's not easy.
Yeah, Laoshi, I just want to know who told Newton and Leibniz to discover calculus?
Okay. For most students, yes, calculus is not easy. I know that. But trust me, I'm trying to find the easy questions, to be honest. So I will give you. I will give you the questions similar to the exercises we take during the class, and and on the test paper. So and I will explain the review paper in detail. So please take notes and and do the questions on the review paper at least 3 times. Maybe that will work. Okay, so let's solve question number 3 here. Question number 3, for this question, you will find first, here we can see cosine x power 5, right? So when you see the power 5, you should know that we can let u be cosine x here, right? So u equals cosine x here. Then du equals d cosine x, and that equals cosine x prime dx, and that equals minus sine x dx, right? So it is similar to indefinite integral when we use substitution rule there, right? So this is the first. And the last step here, don't forget to change the limit for the integration for u, right? So as we know here, x, it takes from 0 to pi by 2, right? So you should know u takes from, we can substitute u 0 first. So cosine 0 makes 1 here, right? So that is 1. And we can substitute pi by 2 here. And cosine pi by 2 means 0 here. So the new limit, that is from 1 to 0, okay? So here we can change the definite integral to a new type, that is from 1 to 0. Cosine x power 5 means u power 5. And then sine x dx here, sine x dx, you should put the minus sign before du, right? So that times minus du here. And that equals, we can take minus out. So equals minus from 1 to 0, u power 5 du. And here, pay attention here. I will use this minus sign to exchange the lower and upper limit here. So that equals from 0 to 1, u power 5 du. I use this minus sign to exchange the lower limit and the upper limit here. The previous, that is from 1 to 0, and now that is from 0 to 1 here. And then we can use the formula directly. That means 1 by 6, right? U power 6. And then from 0 to 1. So that means 1 by 6 here. So here is the solution for number 3, question number 3. Any questions here?
Sure, I have a question. How
Okay.
we got 1.6 from this
Mhm.
row?
Oh, you first substitute 1 into this function. It is yeah.
So, and after that,
minus 0 into this function. So that is say 1 by 6 times 1 power 6, right? And minus 1 by 6 times 0 power 6. So 0 here, 1 by 6. We can get 1 by 6 at last here.
got it, Laoshi.
Okay. Other questions? Other questions?
No, Laoshi.
No? Okay. So I will give you 3 questions for homework. Okay, so I will write here, here 3 questions are the homework. So try to solve it, try to, okay?
So, Laoshi, can we review all of our homeworks and solve it, right?
I think
Okay.
the specific explanation for the homework, they appeared on the notes I sent in the group, right? So
Yes.
yes, so you can check the notes for the procedure of homework. And I will explain all the questions on the review paper. All the questions, one by one. Okay.
Okay, Laoshi. But Laoshi, what I wanted to ask is, can you use your own way to solve the question and get the answer? Or
What?
should we follow your procedure in solving the questions?
If you have other ways to solve it, and the way that is correct, of course, that is okay. But,
Okay.
but I don't know. For example, for this question, number 3, do you have another way to solve it? Can you tell me?
Laoshi, I'll figure it out. Next week, I'll tell you another way to solve it.
Okay, okay. Of course. If you have another way to solve it, that is okay. Okay, and I will check one by one.
Okay, Laoshi.
So I will write the homework here. And please take notes and submit before next Thursday. The first one, that is from -1 to 1. The integral, that is 2x squared plus x cosine x by 1 plus square root of 1 minus x squared dx. Number 2, from -2 to 2, x plus square root of 4 minus x squared outside power 2 dx. And number 3, that is from 3 by 4 to 1 dx by square root of 1 minus x minus 1. Maybe at first, when you see the definite integral here, especially the first one, integral here, you will think you don't know how to solve it, right? Because that is complicated here. It seems complicated, but please think about it twice and use the property we have learned. Think of the properties we have learned for definite integral. So here, I will give you some hint, okay? For the first one, you can separate the integrand here to two parts, and one part that is an odd function. Remember that? When you see an odd function and the interval that is from -1 to 1, symmetrical, right? So you can use the property for odd function. So try to separate it to two parts and figure it out. So this is the hint for the first question. And the second, here, the interval that is from -2 to 2, that is also symmetrical. So we can also use the property for odd function. And the first step, you should calculate this integrand part by part. Use the power 2 formula. So that is the hint for number 2. And number three, here, maybe you cannot work it out directly, but here the hard part, that is square root of 1 minus x, right? So we can use substitution rule here to let u be square root of 1 minus x, and then solve this definite integral. So here are the hints for the 3 homework, and I don't think they are easy ones. So try to figure it out, or you can discuss with your your classmates, or with me. Both are okay. Try to figure it out how to use it to solve it. Okay, guys. And later I will send the review paper to the WeChat group. So please complete the test, complete the review paper very carefully. Okay, guys?
Okay, 老师.
Okay.
老师.
So do you have?
老师, we'll love that if you give the hint as the same you did during our exam. We will love that.
Okay, try your best. I think you can. Okay, guys. So see you next week.
Okay, 老师, thank you very much.
Bye bye.
Bye bye.
Yeah, 老师。
拜拜。
再见，老师。
再见。